Okay, today we will discuss the short notes or the easy way to understand Le-Chattelier principle. So just have a quick review. What does Le-Chattelier principle states? It states that when a chemical reaction, when any chemical reaction, any means any reversible chemical reaction, so it applies only on the reversible chemical reaction is at equilibrium. So what does equilibrium mean? So equilibrium mean when the rate of forward and the rate of reverse reaction are equal. So when the any reversible chemical reaction is at equilibrium and you disturb that reaction. So what are the sources of disturbance? The sources of disturbance are temperature change, pressure change, volume change, concentration change. So when you disturb the equilibrium by changing temperature, pressure, volume, or concentration, so the reaction responds in a way, actually by applying the disturbance, the reaction responds in a way to regain the equilibrium. So reaction tries to regain the equilibrium. So example for this principle is the same as when you are sleeping, okay? And it's a cool morning, a very pleasant weather outside, and very pleasant weather outside. So, and your mom, your dad calls you. So what you do? Uh, you disturbs from the your sleep and you listen to their voice. But what you do at the end, naturally, you again goes to sleeping. So when you are sleeping and your mom disturbs you, means it's the source of disturbance. You are at equilibrium, and then you tries to re-sleep again. Okay. So next one is how we are going to discuss the next key notes of it. So the next key easy notes for this is how the temperature affects. So the code for the temperature is XLF. When the reaction is exothermic and you apply low temperature at equilibrium, the reaction moves forward. So if you are applying high temperature for exothermic reaction, reaction will move backward. So when you are applying exothermic, in exothermic reaction, you are applying H for high temperature, reaction will be moving backward. So opposite for endothermic, endothermic high temperature forward, endothermic and for endothermic on applying low temperature at equilibrium will move toward the backward. So this is the code for to understand the temperature concept. Let's suppose this is the equation for the Haber process. So it forms ammonia and its delta H is minus 93 kilojoule per mole. So what it means? It's exothermic reaction. What will happen if I apply low temperature at equilibrium? So applying low temperature at equilibrium, it's exothermic reaction. Applying low temperature, the reaction will disturb in a way that it will move forward to regain the equilibrium. So the opposite or the vice versa is the case when you will be studying endothermic process. So the other one is code is pressure. So how the pressures are linked? First of all, applicable on gases only, not on the liquids. So secondly, the code for this to understand is HPHL. So by applying H for high, by applying high pressure, H for high, P for pressure, reaction moves from high mole to low mole. So reaction move in the direction of high mole to low mole. So how it would be, let's suppose my equation is example is again the same. So I am reacting it in a way. So I am counting these two things. 3 moles of hydrogen and 1 mole of nitrogen means 4 moles of reactant and total 2 moles of product. So reactants have high mole. If I am applying high pressure, where it will go? By applying the high pressure, the reaction will move toward the low mole, that is the product side. So by applying the high pressure, the reaction will move forward for this process and more ammonia will be formed. So if you say, and you know the simple law, that is the Boyle's law, what is the effect of volume? So what will be the effect of volume? So as we know, pressure is inversely proportional to volume, or you may say that actually volume is inversely proportional to pressure. That is the more appropriate way to express it. So if a reaction is on the applying the high pressure is moving forward, that reaction means this reaction would have applying high pressure mean low volume. So pressure volume opposite. So at applying the low volume at equilibrium, the reaction will move forward. So the last but not the least, that is the concentration. So the concentration is a typically a simple concept. For example, if you add for the reaction, this reaction, again the Haber process. So if you are applying any reactant, like if you are applying or mean adding nitrogen, so you are adding the reactant, so reaction will move forward. So if you are applying or adding any product, for example ammonia over here, the reaction will move backward. So these are the codes that exothermic on low temperature will move forward, exothermic on high temperature will move backward. And similarly, endothermic on high temperature will move forward and endothermic on low temperature will move backward. So these were the some easy conceptual notes to understand Le-Chattelier principle. For any more queries, feel free to text me or contact me on WhatsApp.